Hello, everybody. We are starting our next unit, which is all about polynomials, and we'll learn what a polynomial is today. So once you figure out what a polynomial is, we're going to kind of go through some vocab right away, as you can see at the beginning of your notes. We are then going to add and subtract polynomials. It's very easy. I think you guys will enjoy this first lesson, but I will be honest, this first part of getting through the definitions, it's a little tedious and not the most exciting thing, okay? So let's just get going. So I'm giving you the definition here. Let me hold on one second, you guys. Okay, here is like in letters, or excuse me, in words, a definition of a monomial, and then in blue are different examples. Okay, so just so you know, moving forward, you can write what works for your brain. If you want to write the definition and some examples, or just one versus the other, you do what makes sense. But a monomial is a number, a variable, or a product of the two. And then remember, folks, product means like to multiply, right? Multiply. Okay, so here we have 3. It's just a number. Y to the power 4 is just a variable. And here is that product of the two. That's a monomial, okay? Just one term, okay? That's another way to think of it. Just a one term, because mono means one. A polynomial is a monomial or the sum of monomials. So poly means many. This first part means many. So this really means many one terms together. So as you guys can see, you see how we have multiple terms here connected with addition, or it could be subtraction. That is a polynomial. So multiple monomials in one. And now from here, we can get more specific with a polynomial. You could call it a binomial. Now, a binomial is a polynomial with 2 terms, because this prefix bi means 2. Think of like a bicycle. A bicycle has 2 wheels. Bifocals, like glasses, have 2 lenses. That first part in bi means 2. So do you guys see we have one term here and one term here? It's a binomial. One term here, one term here. This is a binomial. Okay? A trinomial, I think you guys are going to get the hang of this, is a polynomial with 3 terms, right? The prefix tri has 3 terms. Think of a triangle. A triangle has 3 sides. So again, 1, 2, 3 terms. 1, 2, 3 terms. And just remember that they're separated by those addition or subtraction signs. Okay? So a trinomial has 3 terms. Now, a term, this probably should have been said before we went through all of this, it's a single number or variable separated by that plus and minus. But we've kind of already seen that. So this is a term, this is a term, this is a term. We're going back to this example up here. There's 3 terms here. And again, separated by that plus or minus. Now, like terms have the same variable and exponent. So that's huge. It needs to have both to be a like term. The same letter and to the same degree, the same exponent. So do you guys see how we have 3y squared and 5y squared? They both have y squared in common, so they're like terms. Same thing here. 9x to the power of 5, negative 2 to the power of 5 are like terms because they're both to x to the power of 5. This is crucial. Same variable and exponent. Standard form is when writing exponents from decreasing order. So that means you start with the biggest exponent and go to no exponents. So if you guys see here, you guys see how 5 to the power of 5 is our largest exponent there, and then it gets smaller as we go down. Then I go to 3 to an imaginary 1 to no exponent. Same thing here. We start with to the 3rd power, second power to the first power to nothing. Decreasing order for standard form. And then the last thing here on this first page of your notes, the leading coefficient is the number in front when a polynomial is in standard form. So it has to be in standard form, and then it's the number in front. So if you guys notice here, I made it a different color ink. So 9 would be your leading coefficient in this polynomial here. 12 would be your leading coefficient. If we look up to these other examples up here, oops, there we go. What's really in front of this x to the power of 5? An imaginary 1. So 1 would be your leading coefficient there. Same thing here. There's an imaginary 1. So 1 would be your leading coefficient in that one. Again, you guys, I realize I just threw 8 new definitions at you. It's a lot. So I just definitely recommend that you either wrote an example down or the definition or a combination of the two. So the degree of a perfect polynomial in one variable is found in 2 ways. So you definitely have to write both of these things down, okay, folks? Let's look at this first one here. So if it's just a monomial, so just one term, you add the exponents. So if I look here, here's an exponent, here's an exponent. So I add them together, and I get a degree of 5. And this will make sense later when we're going to ask you to classify your polynomials. One of the things you're going to be asked to do is find the degree. And this is how you do it if it was a monomial. It would be a degree of 5. Now, if you have a polynomial, so more than one term, you take the largest exponent. So if I look here, my largest exponent is to the power of 3. So your degree would be 3. Definitely write these 2 things down, you guys, and give yourself an example. Or use the one I gave you. You definitely want to have that in your notes. Because for whatever reason, we forget about this. Okay, so let's take some of these new ideas and practice them. It says write each polynomial in standard form. So remember that's going in decreasing order. Decreasing. So we're starting with the biggest and going down. So if I look here, if I just have a monomial, you can't write it any other way. It just is what it is. We're done. There's nothing else you can do there. Okay, now on number 2, we can actually do something. So my biggest exponent is the power of 2, so I have to now put that first. And you take the sign in front of it with it to be negative x squared. And then what would come next? What's after 2? Yep, 15x, so plus 15x. And then you just tack on that plus 3 because it doesn't even have a variable at all. And that's it. Our next one, what's going to come first out of our 8q or q squared? Should be q squared because it has the bigger exponent. And then finish off with 8q. Right? So that's standard form. Now it says find the degree and classify each polynomial above. So, I wish we should almost write a table for this. Folks, on the bottom of your packet here, on the very bottom of this page, will you write this little table so we know? So under it says your turn. Will you guys write this? So if it's to the first power, it's linear. Second power, it's quadratic. Third power is cubic. Fourth power is quartic. And anything after that, you would just call it a, we won't worry about it. It would be ketic, but we don't need to worry about that. Let's go to 4. So please write those down so we have those as a reference. Okay. So back to this first one, classify by the degree and by the number of polynomials or terms it has. So since this is to the power of 4, if I look at my chart, the 4th power is quartic. And then since there's only one term, it's a monomial. Okay, our next one here. My highest exponent is a 2, so it is quadratic. And since it has 3 terms, it's a trinomial. Now this last one, our highest exponent is a 2, so again it's quadratic. And then it has 2 terms, so it's a binomial. Okay, pause the video. You guys do those next 3 that say your turn. Write each polynomial in standard form, find the degree, and classify the number of terms it has. So the exact same thing we just did. Put it in standard form, so from biggest exponent to smallest one, and then classify. Okay, I'm hoping you did it. I am going to go ahead and start on number 5 here. The biggest exponent would be that 1, so it'd be negative 9z. Remember to take that sign with it, plus 4. Since it's to the first power, it's linear. 2 terms makes it binomial. Our next one here, start with your biggest exponent, would be negative t cubed plus t squared minus 10t. So we're to the third power, makes it cubic. 3 terms makes it a trinomial. Our last one here in standard form, x cubed plus 2.8x. Highest power is 3, so cubic. And let's see here, 2 terms makes it a binomial. Give yourself a gold star if you got those right. And if you didn't, give yourself a gold star anyways. Okay, I will tell you, that first page of this note was a lot of info, a lot to cover. Now, we're going to get into the easier part, the adding and subtracting of these things. So when you add and subtract polynomials, we simply combine like terms. That's all we do. We find out what's similar and we push them together. We're going to mush them together, so we're combining our like terms. So on this first example, for example 4, we have to identify what are our like terms. So I just like to start with my first one. I have a 2x cubed. Do I have any other x cubes around? Oh, right here. So if I add them together, what's 2x cubed plus 1 more? It'll give me a total of 3x cubes. All right. Now I'm going to go down my list. I'm writing it in standard form. Do I have any x squareds? Well, I have negative 5x squared here, plus 2 more here. So negative 5x squared plus a positive 2x squared would bring us to negative 3x squared. Okay. Find your powers of 1. I have 1 here, but I don't have anywhere else, so I'm just going to tack that on. And what do we have left over, folks? Just this minus 1, minus 1. That's it. We combined our like terms. There we go. Let's try another one. So again, folks, I start with my biggest exponent and work my way down. So it appears that my largest exponent is an x squared, so I have 3 here and a 1 there. So 3 plus 1 would give me 4x squared. How many just x to the power of 1s do I have? 1 here plus 4 more for a total of 5x. Then finishing up with just our constants, our numbers. Negative 6 plus 10. You guys, what's negative 6 plus 10? Positive 4. Boom. Done. All right. Adding polynomials is pretty straightforward. We've done that. We've kind of been doing this secretly all year when we're simplifying our equations. You just didn't really realize that's what you were doing. Subtracting polynomials is very similar. However, you have to distribute that negative 1 to the second polynomial first. and then you do the same thing we just did. Okay, so do you guys see how in here we don't have an addition sign? We have that -1. So we have to take this -1 and distribute it through before we can combine our like terms. So let's try that together. So we're going to write down this first polynomial exactly how we see it. We can't change that one yet. And now we're going to distribute this -1. So -1 times -2n squared, well, -1 times -2 makes it positive. -1 times positive 2n makes it a -2n. And -1 times a -4 is positive 4. So really, folks, all that happened there is all of our signs in here became the opposite value. That's really what you have to make sure you do. And now from this point on, it's the same thing we were just doing. So start with your biggest exponent, which appears to be n squared. So I have 4n squared plus 2 more for a total of 6n squared. Go to just your single n's. It appears that I only have 2 of them. And then add your numbers together. 5 plus 4 gives me a plus 9. That's it. Okay, folks, last one here on this little page of our notes. So same thing, distribute that -1 first. So you begin by writing the first polynomial exactly how you see it. And then we distribute. -5 times 3 is -3x squared. -1 times -x, make it a positive x. And then -1 times -8 is a positive 8. Again, folks, all that happened there is these signs became the opposite. And now we combine like terms. X squared is our biggest exponent. So 4x squared minus 3x squared will just give us an x squared. Go to your x's. -3 plus 1 will give us -2x. And then our last, just our constants, our numbers, 5 plus 8 is 13. Okay, the last part is for you to try those bottom 4, and then we will go over them together. Again, I encourage you to pause the video, and then you can fast forward to the part where I go over them to see if you did them correctly. Okay, I'm going to begin. On this one, we're just adding, so I can keep my symbols the same. 1b plus 4 gives me 5b. -10 minus 3 more is -13. Done. All right, another adding one. Our signs stay the same, so we just have to combine. 1x squared plus 7 more gives me a total of 8x squared. -x minus 1 more gives me -2x. And then our -2 doesn't have a buddy, so it just stays -2. Boom. Okay, hope those adding ones were pretty good. No issues there, I hope. These ones, there's a little bit more room for error because you have to distribute. So I'm going to write down that p squared plus p plus 3. Remember, this stays the same. Now we have to distribute. -1 times -4 is a positive 4p squared. -1 times -p is a positive p. -1 times 3 is -3. All right, now from here we can add our like terms. P squared plus 4p squared gives us 5p squared. 1p plus another one gives me 2p. And then let's look here. Colored blue. 3 minus 3. Well, that just cancels out, so we're done. Last one, folks. Again, leave that first polynomial the exact same. Distribute that -1. You get -3k squared plus 6. Add your like terms. I have a k squared, so -3k squared. A k here. Oh, that's it. Can't add that to anything. So -k. And then add your constants together. 5 plus 6 is 11. How did that go? I hope it went amazing. Okay. Good work. Thanks for watching. Let me know if you have questions.